Okay, so for this question, we've got these two carts rolling down two inclines and colliding somewhere in the middle. And we've got a few questions to ask, or a few questions to answer. So the first question is asking, after those carts collide, which way do they move? And there's a few pieces of information, right? We know how their masses compare, we know how the heights they're released from compare, and we know how the angles compare. Now, I think the best way to approach this question is to use a combination of energy and momentum. And if we're going to do that, it turns out these angles don't matter at all, right? All we care about are these heights and the masses. So if the two carts are going to collide and stick together, in order to figure out which way they're going to move, we need to know that once they reach the bottom of those inclines, before they collide, is their combined momentum going to be to the right or to the left? And whichever way their combined momentum is, when they collide, they're going to have to move together in that direction. So that means in order to find what their momentum is each when they're at the bottom, we're going to have to use conservation of energy. So for cart A, in order to find its speed at the bottom, we have to use energy, and we would do something like mg times 2h equals 1/2 mv squared. So if we want to find the speed of that one, it would simply be, what is it, 4gh equals v, root 4gh equals v. And for B, we would have 2mgh is equal to 1/2 times 2m v squared, right? Because it's got twice the mass. So now if we solve this out, we get 2gh rooted equals v. So now let's figure out which way is the momentum of the system. So the net momentum of the system. Now I'm going to go ahead and let's call right the positive direction. So if we do that, cart A is going to have positive momentum, and cart B is going to have negative momentum. So if I plug in what I found before, here the mass of cart A is just 1m, and the velocity of cart A, right, that's up here, that's velocity of cart A, this is the velocity of cart B, so v of cart A is root 4gh, and then the momentum of B is negative because it's moving to the left before they collide. Its mass, which is 2m, times its velocity, which is root 2gh. So now let's just simplify. So what I'm going to do is I'm going to bring the numbers out in front. So here I've got a 2m times root gh for my first term. Right, all I did was I took the square root of 4, which is 2, and I left gh under the root. Right, I'm just trying to bring the coefficients out front, so it's easier to see. And this one I've got 2 root 2 m times root gh. And now we can tell just by looking at it, right, that this negative term is actually bigger than the positive term. So it's going to move in the negative direction after they collide because the net momentum is in the negative direction. So the net momentum is left. So they will move to the left. Move to left. Okay, so let's talk about these other parts of the question too. They're a little bit quicker or a little bit shorter. So B1 is asking about a system consisting of the two carts and the earth, what happens? So a system consisting of cart A, cart B, and the Earth. The question is asking, does the total mechanical energy of this system increase, decrease, or remain the same after the collision? So if we think about this system, if we think about from the very beginning to the end, let's actually do an LOL diagram. And you know what? I'm going to do this on another page. Might as well. So for B1, let's do an LOL diagram. And I know this was an energy thing, but I think it's still helpful. So the two-cart system, it starts with some potential energy. Because the Earth is part of our system. So maybe I'll just write our system as A, B, and Earth. But during and as the carts go down the incline, right, they both gain kinetic energy. And at the bottom of the incline, all of that potential energy would have been converted into kinetic energy. But they collide. And it's an inelastic collision, which means some kinetic energy is turned into heat. So we're actually going to have some energy leaving the system, right, and turning into thermal energy. So that's I guess, I don't know, maybe I'll just label it as thermal. So we're going to have less energy in the system after the collision. There won't be any UG, and here there was no kinetic energy. And here later, we're going to have some kinetic energy in the system, but less than before. So the system loses energy. Okay, so now for B2, it asks us to consider a system of just the carts. So only carts A and B. So in the two-cart system, we start with no mechanical energy because the carts themselves can only have kinetic energy. So we start with no kinetic energy, but we end up with some kinetic energy. So this system gains mechanical energy. And if we think about what's going on, well, it's because the Earth is doing positive work on this system, right? So there's positive work done by Earth. And that kind of happens on both of these objects. And then when they collide, we lose some energy, right? So there's some thermal energy loss too. But the Earth did more positive work on the two-cart system than the amount of energy that we lost when they collided with each other. So overall, the two-cart system did gain mechanical energy. I hope this was helpful.